After running the two-stage least squares regression, we wonder if our instrumental variables are indeed exogenous. And here we have one endogenous variable and we have two instrumental variables, which means that we have over-identified the endogenous variable, which means that we can perform a test of the exogeneity of state tax and cigarette tax. And if you included either one in the regression, you would believe that they are exogenous if they provide the same end result down here in the two-stage regression, and if they did not provide the same result, the same coefficient on LMP, then you would believe that at least one of them is endogenous. So what we can do, instead of running these two-stage least squares regressions and compare the coefficients, we can join the test into one. So what we can do is that we just run the regression, I regress two-stage least squares, and our dependent variable is ln(q), the quantity, and our endogenous variable is lnp, which is the log price of cigarettes, and this is explained by two instrumental variables, the state tax and the cigarette tax. And we have one control variable, which is the ln inc, which is the logarithm of personal income or per capita income. And we run this regression and we obtain our coefficients. And the second step in the J-test is to predict or to get the residuals. And we do this, we now have residuals as a variable, and we can now regress that variable on the instrumental variables and the control variable, because the control variable is in the regression such that state tax and cigarette tax should be uncorrelated with the error term, right? So ideally, when you predict the residuals here, you should use not the fitted values of LMP, but you should use the observed values of LMP. Here we are using the fitted values, but this is an approximation. Just see Woolridge 2009, and so we have this approximation. Later on, we are going to use the more specific method to run this test. But these steps will show you how, or show you what this test is actually doing. So we are regressing. We are trying to explain the variation in the residuals by using the information in our two instrumental variables and the control variable. And we run this regression. We see that independent variables here, the state tax, and ln inc, they do not explain much of the variation in the fitted residuals, and the f-test here is rejecting that together these do have at least one slope different from 0. And what we do now is that we run a test on the state tags and the sig tags, the two instrumental variables, to see if they are, no, let's see if we can just get the test state tags and sig tags. This is a joint test of these, where the null is of these being equal to 0 jointly, and we get an f-test or f value, and the probability of getting this result, or more extreme, is 85%, so it's quite close to 0. And the fifth step is to calculate the J-stat. And the J-stat is di, just means display. You could just write the display, then you would get a printout of this number. And because you have two instrumental variables, times the f statistic from the test here, and you get 0.307, which is the J statistic. And now we have to compare this to a critical value, and if this number is above the critical value, then we reject the null hypothesis of exogeneity. So if the instrumental variables do have some explanatory power of the variation in the residuals, then we say that they are not exogenous, they are endogenous. So let's see. We have to find the critical value, and we use m minus k, which means that we have m instruments minus k number of endogenous variables. In our case, we have two instruments minus one endogenous variable, which means that we have 1 degree of freedom, and we are assuming a 5% significance level, and the critical value is 3.84, and we find that from the F table, and here we have the F of m degrees of freedom with infinite number of observations. This is really not what we are looking for in our case, because we only have 48 observations, but it's if you are doing this analysis, like empirical analysis, then you would use more data. So we use this table, and we have 5% significance level, and we have 1 degree of freedom, so the critical value is 3.84. Okay, so, and since our J-stat is less than the critical value, then we say that we cannot reject the null hypothesis of exogeneity. which means that we are led to believe that these two instruments are indeed exogenous. So this means that we can use them to extract the exogenous part of the price and get a valid result in the two-stage least squares method. We can also find the critical value by use of Stata. So it's an inverse chi-squared distribution with 1 degree of freedom, and the confidence level, not the significance level, the confidence level is 95%, which means that we have 3.84 here as our critical value. And if we had one extra instrument or instrumental variable, we would have 3 instrumental variables minus 1 endogenous variable. We would have 2 degrees of freedom, and we would have a different critical value of 5.99. So you can easily use Stata to find the critical value to which you compare the JSTAT. We can check this critical value such that we are certain that it corresponds to the 95% confidence level, and we have display chi-squared distribution, degree of freedom equal 1, and the value of 3.84 corresponds to a confidence level of 95%. And you can also find the p-value of the J statistic by Stata, and you just write display chi-squared with 1 degree of freedom, and you have the J statistic here, and you find the p-value. And in 42% of the cases, you would actually expect a more or a higher value of this process just by chance. Instead of going through all these steps, which is quite cumbersome, and well, they were useful to just show you what's going on, you can always in Stata do something more elegantly. And in this case, you can just write estat over id to get the overidentifying test. However, we need to run the regression again, the two-stage least squares regression, and then straight after you have run this regression, you can just write estat over id. Estat is a function which enables you to run tests on the results from statistical methods. So in this case, we have the over-identifying test, and we see here that we have a chi-squared score of 0.33, which was quite close to the number which we got from the manual method. But it's not exactly the same, because this accounts for the fact that we have to use the actual observed prices in order to calculate the residuals. Whereas in our manual J-test here, we predicted the residuals with the fitted price values from the first step regression, but they they are quite close, and quite seldom they do not correspond. But the p-value is 0.56, so we do not reject the not null hypothesis of exogeneity.